Hey guys, in this video we're taking our first look at sketching reciprocal graphs and graphs of functions with other negative powers. So in this one we're only going to look at the more simple ones. Once we've gone through some graph transformation stuff, which is the next topic, the next section in this chapter, we will come back and look at more complicated ones. So, first of all, what's a reciprocal? Well, a reciprocal is when we have something in the form y equals k over x, which we can write as kx to the power of minus 1. So, this is our most simple reciprocal. We will be looking at other negative powers too, but we're going to start here. So, these are our reciprocals. Y equals k over x, where k is a constant, which we can also write as k times x to the power of minus 1. Now, with graphs like this, we run into a bit of a problem with specific values, in particular with these simple ones when x is equal to 0 and when y is equal to 0. We'll see why in a moment, but these two problems create these special lines for us which are called asymptotes. So an asymptote is a straight line which is usually dashed, but here for these first few examples, in fact for the whole of this video, our asymptotes are going to be our axes. So it's a bit hard to dash the axes and still have them looking like the axes. So an asymptote is a straight line that a curve can get infinitely close to, but it will never ever touch. So the reason that we get asymptotes is, so as I just mentioned, if we first of all think about x, what happens when x is equal to 0? Well, we are then trying to divide by 0, which you can't do. It's one of the biggest sins in maths when people accidentally think that they can divide by 0, which leads to a major cock-up. You can't do it, it's undefined. So when x is equal to 0, k divided by x doesn't exist, so it's undefined. But what is going to happen here, as x gets really big, then k over x gets really small. If we did k divided by a massive number, that's going to give us a really small number. Or, as x gets smaller and smaller and smaller and smaller and smaller, so something like 0.00000000001, k divided by that is going to be massive. So when x is equal to 0, we have this asymptote, and what happens, that makes the y-axis an asymptote. Y-axis is the line x equals 0. So as we get closer and closer and closer to the y-axis, from the right, when x is positive, the y value shoots up to positive infinity. Or, as we approach it from the left, when we've got negative x values, the y value shoots down to negative infinity. So that is why the y-axis is going to be an asymptote for us. We'll see the graphs in a moment. Now we also have another asymptote, and that comes from the fact that k over x can never equal 0. Whatever k is, k has to be a constant, not equal to 0, otherwise we've just got y equals 0, which isn't very exciting. There is no value of x that can make this fraction equal to 0. So that also makes y equals 0 an asymptote. So y equals 0 is the x-axis. So the x and y-axes are asymptotes. Okay, so here's our graph of y equals 1 over x. So this might look familiar. For those of you that haven't realised yet, we are dealing with inverse proportion. So as x gets bigger, y gets smaller. So if we first of all check out what's happening in the top right part of the graph, as x increases, so as it scuttles away off to positive infinity, the y value of the curve is getting smaller and smaller and smaller and smaller. It's tending towards the x-axis, but it's never ever going to touch it because the x-axis is an asymptote. Or, on the flip side, as x is getting smaller and smaller and smaller and smaller, so closer towards the y-axis, the value of y is shooting off up to positive infinity. Now, sometimes we might be asked to plot certain points on these graphs, so when we've got y equals 1 over x here, we can easily substitute in x equals 1, for example. Now when x is equal to 1, y is also equal to 1. We could substitute in x equals 2. Now when x is equal to 2, say that's somewhere over here, y would be equal to 1 over 2. So 1/2. So we can do that as much as we want. So down here in the bottom left then, what's going on? Well, as x shoots off down to negative infinity, the value of y is coming closer and closer up to 0. So again, it's never ever going to reach 0, but it's getting infinitely close to 0. Or on the flip side, as x is getting closer and closer up towards 0, so x is getting bigger, so less negative, the value of y shoots off down to negative infinity. So that's what our graph of y equals 1 over x looks like. Okay, on the flip side, here's the graph of y equals minus 1 over x. So already we're getting a little bit into transformation of graphs territory. This looks very similar to y equals 1 over x. It's just a mirror image reflected in the y-axis. So this is what y equals minus 1 over x looks like. Now, the graph of y equals k over x looks very much like these guys. Pretty much identical. You just get slightly different numbers depending on your value of k. So to work out some numbers, you would just substitute in x values. So you can sketch these graphs y equals k over x or y equals minus k over x is always going to look like these two graphs. If you need to put coordinates in, just substitute them in and make them look accurate with your sketch. So now we're going to take a peek at other negative powers. Okay, so when we have other negative powers, so something in the form y equals kx to the minus n, or y equals k over x to the n, there are two general cases, when n is even and when n is odd. So, first of all, let's have a look at when n is even. So, for example, if we had y equals k over x squared, and n is even, n is 2, what happens with even reciprocal graphs is that you have two parts of the graph, and they are opposite sides of the vertical asymptote. So here, with y equals k over x squared, we have symmetrical parts of the graph opposite the y-axis. Now, when k is positive, they are above the x-axis. So for example, we have y equals k over x squared. So that's the blue graph here, when k is greater than 0, so when k is positive, or if k is negative, we would get this purple graph down here, where we are opposite sides of the y-axis, and we're symmetrical, and we are also below the x-axis, or when the n is odd. So here, for example, I've got n is equal to 3. We get this sort of situation, so the graphs are in diagonally opposite quadrants to each other. So at the top right and bottom left is the graph of k over x cubed, where k is greater than 0, so it's positive. So when k is positive and n is odd, our graph is in the bottom left and top right quadrants, diagonally opposite. Or with the orange curve, when k is negative, so less than 0, our graph is in the top left and bottom right quadrants. So remember, when we get into the trickier ones, it's not always going to be the x and y axes, but when we got these basic ones, it is. So there are your general cases. Hopefully you found this useful. That's it for this video. Up next, we're starting to look at transformations of graphs. So we'll be seeing these guys again. I can tell we're all very excited. Good times. Take care, guys.